Look at these images. These images were taken by the James Webb Space Telescope. It was launched last year and was being set up since then, but now it's ready. This week NASA released some of the very first images taken by this telescope, and these images are much better than we ever had. JWST is taking astronomy to another level. For comparison, look at these similar images taken by the Hubble Space Telescope. You can immediately see that JWST is able to see more stars and galaxies, and the structures of these nebulas and galaxies are much more concrete and clear in the JWST image. And it is kind of expected, as JWST is way better than Hubble in every metric. First of all, on Monday, we got this image. This is the deep field image of galaxy cluster SMACS 0723, taken by the Near Cam detector on Webb telescope. You might have seen a similar kind of image taken by Hubble. It's good, but Webb's image is much better. Here we are able to see the faintest of stars. Some of them are even more than 13 billion years old. That means when the light from these galaxies would have been released, the universe was less than a billion years old. Therefore, we are seeing these galaxies as they were billions of years in the past. Some of them may not even exist anymore, but their presence is marked by the light they emitted. And since our universe is expanding, light from this very early universe is getting redshifted. That means the most distant objects can only be seen in lower wavelengths of light, such as infrared. This is why JWST is designed for observing infrared light instead of the visible light that Hubble uses. Therefore, JWST can pick up the very oldest and faintest light in the universe, which had gotten redshifted to the infrared range. It will be able to see the formation of the very first stars and galaxies, which would tell us a lot about the early universe in the Big Bang, and can bring light to the mysteries that were till now hidden from us. And if you look close, you'll see these stressed out galaxies all around. This is the result of gravitational lensing predicted by Einstein's theory of gravity, according to which when light passes close to massive objects like galaxies, it gets bended, which makes the object look much brighter and distorted. And then we have this image of the Carina Nebula. Here what we are looking at is a star-forming region in the Carina Nebula. The structures that we can see are made of dust clouds and gas. These places are stellar nurseries where new stars form. You can see again the JWST has much more information in its image. It can almost look through the nebula to all these background stars which were previously unobserved. The reason Webb was able to look through this has to do with the fact that it uses infrared light and not visible light to see objects. And the difference comes from the fact that visible light is scattered a lot by these dust particles and gas clouds. So when we try to look for visible light from the background stars, most of it gets stored by these dust clouds and never reaches the telescope. On the other hand, infrared light can pass right through these dust clouds almost like they don't even exist. It is similar to how blue light gets scattered more easily than red light. After that, we got a look at Stephan's Quintet. This image contains 5 different galaxies. 2 of those are in the process of getting merged. The main highlight in this image is the topmost galaxy, where we can see dust and gas swirling to the center. The data shows that there is an active galactic nucleus in this galaxy, which means it has a supermassive black hole with an accretion disk surrounding it. Again, this is the Hubble counterpart. The difference is profound. JWST sees much more in this universe. The next one for us is the atmospheric spectrum of the exoplanet WASP-96b. The data we are seeing here is collected by Webb's inbuilt nearest detector, near infrared imager and slateless spectrograph. And probably this is the most underrated of all the beautiful images released by JWST this week. However, this is just as important and fascinating. The exoplanet is about 1,000 light years away from us. When the light of its host star reaches the atmosphere of the planet, some of the light gets absorbed while some of it gets through. This light, when reaches the telescope, the inbuilt nearest detector splits the light into a spectrum. This spectrum can tell us a lot about any exoplanet's atmosphere, which gases are present in the atmosphere, the composition of its clouds, and it can potentially detect biosignatures in the exoplanet. As in this case, it has detected the presence of water vapor. That doesn't mean there's life on that planet. For one thing, it is extremely close to its host star, and with average temperature more than 1000 degrees Fahrenheit, it's not habitable, at least not for us. However, signs like these would play a key role in finding potentially habitable planets, or even planets that might have life in them. Webb is much better in doing this compared to any other telescope. There is also a transit light curve released of this planet. It tells us about the change in brightness of the host star when a planet passes around it. This can tell us about the mass, diameter, and orbit of the exoplanet and would be really helpful for currently unknown exoplanets. At last, we have the Southern Ring Nebula, which was formed when a star died in a supernova explosion. What remained of the star was a white dwarf, which can be seen in this image. Our Sun would also have to suffer a similar fate in about 5 billion years. There are two images from the Webb telescope that we got for this nebula, one from NearCam and the other from Mirror detector. Both are showing a different story. In the NearCam image, we can see all the background stars and the full extent of the nebula with the complete shape and structure of the gas cloud, while in the Mirror, we can clearly see a binary pair of stars. The second star, the blue one, was not observed before. It is now that we gotta know that it's actually a binary system. Like, we have it theoretically known, but we didn't have observed it. These images are just the start. The science we'll be able to do with such observations would really be a never before experience. It's likely that the Webb will be operational for about 2 decades, which means there's a lot of such images that's gonna come up and lots of science that's gonna happen. And we'll be able to understand our universe much better. I'm personally really excited for 2 things. First, life beyond Earth and the observation of the early universe. We really don't know what we'll find out there. Thanks for watching.